How many different ways can you arrange something? So if you're looking at different arrangements, that's referred to as a combination. If you're just looking at different ways you can kind of group something together, that's a combination. With the permutations, the order in which you select them or arrange them makes it a totally different situation. With a combination, the order in which you select them or arrange them does not make it a different situation. So combinations, order does not matter and is not important. Permutations, order does matter. Now, if you're dealing with permutations, you can use your formula here, or you can actually do it on your calculator quite easily. N is the total objects you have to choose from. R is how many you are selecting. Same with combinations, but the formula is slightly different, and still the number of objects you have to choose from, and R is how many you are selecting. But you also have this extra R factorial down here. Now, if you have a permutation in which you have some objects that are being repeated, then you have to use this formula here. Now, depending upon how many objects are being repeated, you might have more than just p factorial and q factorial on the bottom. You might also have r factorial and s factorial if you would have 4 different things being repeated. So let's go ahead and take a look at a problem. We have 8 people that entered a contest. How many ways can blue, red, and green ribbons be awarded? Well, that's a different situation because if Bob gets blue and Jerry gets red and Rob gets green, that's totally different than if Rob gets blue, Jerry still gets red, and Bob gets green. So the order in which you would select them or assign them makes it totally different. That is a permutation. So we're going to do our permutation. We have 8 objects to select from because we have 8 people. So we're going to go 8 factorial, and we are only selecting 3, red, blue, and green. So we're going to go 8 minus 3. So if you work that out, it's 8 factorial over 5 factorial, ends up being 336. So how could you do this with your calculator? Well, one way you could do it is you could go 8 math over to prob down to number 4, which is your factorial button, divide, and you could go 5, arrow over to prob after you hit math, down to number 4 for your factorial button, and you could hit enter and you get that. But it's a permutation. An easier way to do that is to just hit math, arrow over to prob, and then select number 2. That's your permutation. So the first number is 8. The second number goes afterwards is always smaller, and that's 3. I type that in, and I get my answer of 336. So down here, we're looking at how many different ways we can arrange the letters of banana. Arranging them, the order does make a difference. It's a permutation, and we have repeated elements. Because we have A showing up 3 times, we have N showing up twice. So the total number of letters you have to choose from goes on top. Then, if something's being repeated, you put it on the bottom. You have A being repeated 3 times, so you're going to put 3 factorial. You have N being repeated twice, so you're going to put 2 factorial. So now we need to work this out. And the easiest way to do that is to use your calculator and type it in a very similar way. But there is no shorthand cut for this. So you're going to go 6, hit math, arrow over to prob, number 4. Then we need to hit divide, and I got to put the whole bottom in parentheses. Now you could go 3, then math, or arrow over to prob to get the factorial button, then 2, and so on. But 2 factorial is 2 times 1. 3 factorial is 2 times 3 times 1. So I have 6 times 2, which is 12. So I'm going to just type in 12, and I get 60. So there's 60 different quote-unquote words you can make with the letters of banana. So try to do these two quickly, and then watch the video. Here we're awarding, once again, people different colored ribbons. So the order in which you select them makes a difference. So it's a permutation. We have 10 items to choose from. We have 4 different ones we're selecting for red, blue, green, and yellow. We type that into our calculator. We get 5,040. Here we're looking at these being arranged, so it's a permutation. And we have repeated elements of the A's, so we're going to go the total number of letters over our repeated elements. It's only A that's being repeated. It's being repeated twice, so we go over 2 factorial. We type that in. We get 2,520. Read through this quickly. 6 cards are being drawn. We want to know how many ways we can get 2 hearts and 4 spades. Well, we need to look at the heart situation. Does the order in which you would select 2 hearts really make a difference when you're looking at it in your hand? If you would first get a 7 of hearts followed by a 10 of hearts, it doesn't make a difference or a different situation if the first time you were dealt 10 of hearts and then the 7 of hearts. So the order in which it's selected does not make a difference, so it's a combination. There's a total of 13 hearts to choose from. You're selecting 2 of them. Now, with the spades, it's still a combination because the order in which they're put in your hand does not make a difference. And there's still 13 spades because each suit has 13 and you're selecting 4 of them. So you'd want to type this into your calculator. You'd figure out the green, figure out the blue, multiply that together. Now, how do you figure out the green? Well, you'd pull up your calculator and you would go 13, math, arrow over prob, select number 3 for combinations, and then 2. If you wanted, you could also arrow to the right, and then you could type in the next one for the blue, and do it all in one line. So I'll go 13, math, arrow over to prob, number 3 for combinations, and then you could type in 4. And you would get the same answer. So combinations and permutations, the formulas are already pre-programmed into your calculator. So consider this one here. 6 friends. 3 of them decide that they're going to go pick up a movie. How many ways can you choose 3 people to go? Well, the order in which they're selected doesn't make a difference because if it's Bob, Rob, and Jerry, that's the same group as it is if it's Jerry, Rob, and then Bob. So the order doesn't make a difference, so it's a combination. You have a total of 6 to choose from. You're selecting 3. You type that in on your calculator and you get 20. Try to do this one here quickly and then watch the video. It's a combination situation. You have 13 hearts. You're selecting 6. Then you have diamonds. You have 13 diamonds. You're selecting 7 diamonds. So then you can type that in and you get this relatively big number, 2,944,656.